In this video, we're going to review how Coulomb's law works. It's based on the fact that there is an electrostatic force of attraction or repulsion in matter. That force is proportional to how much charge on two bodies and to the distance between them. So it drops off as 1 over distance squared. So if I let's assume that the force on the bottom here is in fact, let's say, 10 newtons. If I double the distance between the charges, so now it's 2r instead of r, what will be the force? Well, the original force is equal to 10 newtons. The new force is going to equal to divided by 2r squared. So the new force will be 1/4 k q1 q2 over 2r over r squared. So the original force was 10, this was 10. Now this will be 1/4 of 10. So that would be 2.5 newtons. What if both the distance and the charge changed? Let's do an example of that. Let me first erase this material. So supposing we have a force between two charges, so let me put this one back here. Say the distance between them is r, and say we triple the force, of course, is given by k, q, let's call this little q, and let's call this big Q, over distance between them squared. Let's say now we do two things. We triple the charge, so this Q, this new Q will be now 3 times the old Q. And at the same time we bring them closer together, twice as close. So R now is going to be 1/2 what it was before. Let's see what the new force is. Let's call it F prime, and it's going to be K Q. Now the new Q is going to be just 3 times the old Q, so it'll be 3Q. And of course the distance, the new distance, is not going to be R, it's going to be 1/2 R, but don't forget you have to square it. And so the new force between them is going to be 3 divided by 1/4, that's 1/2 squared, K Q Q over R squared, which tells you it's 12 times, 3 divided by 1/4 is 12 of what it was originally. Of what it was over here, 12 times that. Let's take a look at another example. In this particular example, we have just basically 2 charges. They have opposite charges. One is 6 microcoulombs, the other one is 4 microcoulombs. Calculate the force. We didn't actually do the calculation before, but now we can do the calculation using this formula down here. keeping in mind that K is equal to that number. So that force is equal to K Q1 Q2 divided by the distance between them squared, which is 2 meters here. So we're going to put in all the numbers. 9 times 10 to the 9th, that's K. And units are Newton meters squared per Coulomb. Multiplied by Q1, which is 6 microcoulombs. Keep in mind that a microcoulomb is times 10 to the minus 6, multiplied by minus 4 microcoulombs, divided by the distance between them, which is 2 meters squared. And if you do the calculation, you will get 0.054 newtons. Let's use that for a little more complex problem. Let's say we have a problem like this where two charges are placed at the charges are placed at the origin. That's Q1 is placed at the origin over here, and one 2 meters to the right of it, Q2, and one 2 meters to the left of it, Q3, all different charges. What is the force on the 4 microcoulomb charge due to the other two? So basically we need to calculate what is the force between the two red charges and what is the force between the blue charge and the red charge on the right. So the two red charges are the same charge, they're both negative, so that means they will repel one another. So that force will be a force to the right. Let's call that force F1. Now the blue charge here and the red charge are opposite, so they will attract one another. So there will be a force to the left. Let's call that F2. So let's calculate those two forces. So F1, let me do that in red, F1 is equal to K Q1 Q2 over R squared. Once you put in the numbers, will come out to be minus 0.054 newtons. And the minus comes from the fact that this charge is negative, right? Not the charge, right? And it's attracted by the positive charge, so the force is to the left in this direction. F2, using the other two charges, K Q3 Q2 over 4 squared. The distance between them is 4 squared. Over here it's 2 squared. But over here it's 4 squared because the distance between these two charges right here is 4 meters. And if you do the calculation, you get there 0.018. The total is the sum of these two. If you add them up, they come out to minus 0.036. The minus tells you that the net force is to the left because the bluish one is bigger than the reddish one.